Hi, social network analysis is used quite extensively in a wide range of applications and disciplines. In design research, there is a lot potential we can apply social network analysis. You can be one of the first people who adopts a new method. Often the relationship of characters are depicted in this way. But using a social network analysis, we can visualize the relationship in a more comprehensive way and quantitative way. For doing so, we need to transform the novel story into the application data for social network analysis. In other words, we need to define node and link. A node is a single entity, and a link is linking two nodes. In Zhang Valjean's case, we can imagine that every single person can be assigned as node. Now, how can we decide and quantify the link? At least there should be a strong link between Zhang Valjean and Cosette, or between Cosette and her fiancé Darius. One idea is like this. This novel consists of more than 300 chapters, and in each chapter, some of the characters are appearing. Sometimes many of them, but sometimes only Zhang Valjean and Javert. So the link is created, or links can be created when the characters appear in the same chapter. Consequently, Zhang Valjean, the main character, will have a big number of links because he should have been appearing almost entire chapters throughout the story. Javert will also have many links, but mainly with Zhang Valjean, because every chapter he was appearing, he had something to do with Zhang Valjean. Once you have the data about nodes and links, you can easily perform network analysis supported by softwares. Moreover, many of them are shareware. Let's consider another example. All of you participated in this survey. In the survey, you tried to link two entities and defined what information is transferred to the other or both share each other. For example, one of you proposed an idea that a clock sends time information to TV. A clock and a TV are the nodes. And there is a link between a clock and a TV. In this case, this link has the direction. The direction is coming from a clock and toward TV. Again, the key point to apply the social network analysis is how to define nodes and link. After that, you need to collect the data and let a software work for you. As we have seen from the previous two cases, we can use social network analysis in order to visualize the pattern of a relationship that connects social actors. The social actors is implying the nodes in the network. And then secondly, to identify the characteristics of the network in terms of structure, centrality, cohesion, equivalence, etc. Basically, social network analysis views social relationships in terms of network theory. And the social network analysis consists of nodes representing individual actors within the network, and then links which represent relationships between the individuals, such as friendship. These networks are often depicted in a social network diagram, where nodes are represented as points and links are represented as lines. A social network diagram in this slide illustrates the relationship among Korean politicians. The network was created based on the transaction of political fund. You only need two types of information to draw a diagram. The first thing is node. It indicates social actor or entity. In case of this diagram, each politician corresponds to a single node. The other thing is link or edge. It indicates the relationship between entities. In case of this diagram, the money transaction is considered as a link. As an additional information for a link, it can be directed or undirected. If it was surveyed with directed link, this social network diagram should display from whom to whom the money was moved. In fact, when you zoom in this diagram, the lines are arrows. You see? Yeah, they are arrows. So the links are directed, or the links have directions. Also, the thickness of each link is different. So the links are weighted, or the links contain also weight informations. We can predict that the weight of the link in this chart may indicate the frequency or the amount of the money. And I now here find in the caption that the thickness is actually indicating the amount. Okay, so based on this diagram, Mr. Lee Jae-oh, Kang Sung-sik, Han Myung-suk, An Hee-jung are centers of collecting political funds. So node and link are the key components of the network analysis. It is equivalent to defining a variable in other inferential statistics. Let's consider the following four examples. In each case, you are provided with a social network diagram. Based on the diagram, we can find the node and we can predict what link indicates. In the first diagram, countries are linked and links are not directed. Therefore, we can predict the links indicate a mutual relationship such as FTA agreement. In the last diagram, two sets of entities are included, a group of people and a group of books. And the people are linked to books. So we can predict that a link indicates an act of reading a book. In this way, please try to define nodes and suggest any ideas for the links for the second and third examples. They are actually the first and the second quizzes before class. Coming back to the IoT analysis which you participated, Ms. Kim Eun-jin performed a social network analysis using Gephi software. Each of you submitted 10 different scenarios relating household items in a context of IoT. One of the scenarios was, after he entered his office, a worker changes his office door sign into "in" using his smartphone. Based on this scenario, and thanks again for your contribution, So based on this scenario, Eunjin converted this scenario into a network source data. Smartphone transfers the information about user status to door sign. Therefore, a smartphone and door sign are two nodes. The data transaction implies a link. In this way, we collected links with directions, but in this diagram, actually, we considered the link as not directed. So Eunjin converted all scenarios into a set of node and link information using the Gephi software. She made this very appealing, very attractive diagram. The descriptive statistics about a diagram are presented in terms of average degree, average weighted degree, graph density, diameter, average path length, and there could be more. Weight of a link or edge means the frequency in this case. The thickness of the edge corresponds to the size of the weight. Therefore, we can predict that a lot of your scenarios were made based on sharing information between user and mobile devices, such as smartphone. User mobile are the first centralities. The second group centrality includes TV and lighting, and so on. In addition, there are different techniques to emphasize different aspects of the social network data. You can apply different algorithms. Among many, there are two which are more frequently used than the others. Moreover, depending on the criteria, the size of nodes varies, even resulted from the same algorithm. In degree counts when a node is directed from the other nodes. Out degree counts when a link is coming out from that node. When you don't consider direction of the links, the results was like the example 1. Therefore, we can find that user gives information, whereas TV mainly receives information, because user node in out degree centrality is much bigger than the other nodes, but in degree centrality, TV node is much bigger than the other nodes. Using this software at www.gephi.org, you can try out different and very inspiring network diagrams. I asked Eunjin to share her data with me, and here you are presented with how she made the diagram in Gephi software. So as we learned, we can apply different algorithm. So instead of this method, if I change this to this Fruchthammer-Reingold and run, then you see that it's kind of the distribution is normalized, so it's more fit to a circle. And instead of between the centrality, if I click in degree and apply, then the the centrality nodes are changed to different entities. And let's go to the data library. Then we see that here she arranged the nodes data and edge data. Based on your survey data, she manually worked to convert the scenarios to the data that are applicable for a social network analysis. So there could be different way to interpret the scenarios in order to extract the nodes information and edge informations. At KLMS, you can find this data set and you can use this to try out the social network analysis in Gephi. And this data is about the Zhang Baozhang novel, and this already provides you how many times different characters were appearing together across different chapters. So in Gephi, we can start a new project, and let's call the CSV data, which is provided at KLMS. Import spreadsheet. Dataset has only 3 columns, and the first 2 columns are indicating 2 people, and the weight indicates that how many times these 2 people were appearing together in a same chapter. So well, the names are very difficult to pronounce. So for instance, Zhang Baozhang and this person were appearing only twice, which means they were appearing together only in 2 chapters among more than 300 chapters. And this 3-column information is about the edge table, because this weight is about the weight about the link or the edge between these 2 people. So you click the edge table, then go on. Here you are presented with the edge information. So between these 2 people, the weight is 2, and these 2 people and weight is 5, and so on. And if we go to nodes, then the characters, nameable characters are listed. And then let's go to the overview. Here, it doesn't look very attractive, so let's try to decorate this network. Just by changing the method to this Wi-Fi who, suddenly this network look interesting, and I think you can elaborate this network more informatic and also aesthetically appealing. Here are the attributes what we are supposed to check out from a social network diagram. The terms seem to be familiar, but when you look into them, some of them sound quite unusual. They are categorized into 4, and the first 2 are namely the basic descriptions. I'm going to check one by one. First, some attributes related to structure aspect of a social network. Mainly, the attributes are for describing the shape of a network. These attributes are especially relevant when you compare more than one network. Using the attributes of structure, you can describe a network and compare one with the other. Then let's see what each indicates. Number of edges or number of links means an accumulated quantity of link. If 2 social network diagrams have an equal number of nodes, it would be an idea to compare the number of links of each diagram in order to see which one or which diagram or which network has more traffic. And then density. Density means network density. It is a ratio of actual connections to entire possible connections. So when the number of a node is n, the possible connections equals to n multiplied by n minus 1 and then divided through 2. Then average degree. Average degree indicates that how many links are connected to every node. So you divide the total number of links through the total number of nodes. And the mean distance is a mean value of distance between any two nodes in the network. Then a diameter. A diameter refers to the longest distance within a network. When we go to page 7, the diameter was 5. This means that the number of links is 5 when we take the farthest two nodes within this network. Perhaps these two, 1, 2, 3, 4, 5. Second, it is about centrality. Differently from the structure attributes, the following attributes are to identify important nodes within a network. Then let's see what it indicates. Degree centrality is related to the criteria of a node size in the previous slide. When links are undirected, degree centrality is simply a number of links. When links have directions, then it will be either in degree centrality or out degree centrality. For example, in a Facebook, if you are usually receiving friend requests, then your in degree centrality will be quite high. However, if you are usually requesting others to be your friends, your out degree centrality will be high. Therefore, each person should be a single node in that network. Then closeness centrality and betweenness centrality, etc. Closeness centrality means how close one node is to the other nodes. When a node has a small closeness centrality, it is predictable that that node has a role of centrality. In this way, betweenness centrality should refer to an indication whether a node has a function of a mediator. Third, cohesion. Cohesion is to identify how an entire network consists of subgroups. Depending on how you would define subgroups, there are different techniques such as component, clique, community, etc. Last, equivalence. Equivalence, unfortunately, in Gephi, it is not provided. The equivalence here refers to the equal role among different nodes. As types of role, there are coordinator, representative, gatekeeper, itinerant blocker, liaison, etc. Now here you are provided with the different types of software available. Some of them are shareware, so they are for free, and some provide fantastic visualizations. After reviewed all of them, I think Gephi or Gephi could be a good optimization It is a shareware software and you can download it at www.gephi.org. As a tip for installation, Gephi may not operate if your computer has higher version of Java 7. In that case, remove your current Java and then install Java 7. Install both 32-bit and 64-bit, and then download and install the Gephi. And then lastly, the quizzes. Regarding the question 3, you can try to draw a social network diagram with a given dataset using Gephi. You can find this dataset at KLMS. But just in order to answer to this question, you can find already finished diagrams in internet drawn by other people. And then I'd like to recommend you this book. This book was written by 3 professors of KAIST. Particularly, the first part was written by Professor Lee Ha-ung, and he points out a real exciting points of a social network analysis. In his part, Professor Lee Ha-ung starts the question how we can efficiently prevent the AIDS using the social network diagram. Currently, this book is only in Korean. Then the last question of this semester is provoking you or evoking your interest to apply the social network analysis to design context. The core question is actually this. Alright, how did you like the class this semester? It was the first time for me to try a real education 3.0. I never had students like you who invested so much time and efforts to learn the class material before the class. I do appreciate your commitment and I hope this experience was not bad. Thanks again and see you in class.